Hello everyone, you are welcome to the Bioedu Hub, a new science series we are starting for the year 9 student. This is based on the New Zealand curriculum and we are continuing uploading the science lessons for you, and it will be easily guide up to understand your year 9 science lesson in the school. Please stay in touch with me. So today uh, we are focus on the Today we are focusing on the first lesson, the laboratory, its equipment and the safe use. I think you have seen the science laboratory. Normally the lab is designed for carry out the experiments and undertake the investigative inquiries. So within the science lab, there's a lots of equipments available for you to use. So year 9, when you come to the high school and when you're going to the science lab, you will see lots of equipments. So in this video I am going to show some of the basic instrument you are seeing in the lab and how we are going to draw in a scientific way. Everybody know about the first uh, thing here, instrument equipment is a test tube. So test tube mainly used to mix or heat small amount of liquids. So normally it's hold about 10 milliliters. And also in the lab you will see the boiling tube. So boiling tube and the test tube is different. So boiling tube we are using to heat a small volume of liquids to until it's boiling. So it's the capacity is much higher. It's around 30 milliliters. And then the beaker. So why we are using a beaker? So you can collect, mix and heating chemical in the beaker. So in the beaker normally you can see there's a calibrations. So based on that you can find 50 milliliter beakers, 100, 250 or 500 or 1 liter or more than that. So when you are in the lab in the next time, have a look how many types of beakers you have. So their volumes are different. If you are trying to measure 100 milliliter, so you better to use 100 milliliter beaker. And the next one is filter funnel and paper. So this is a filter funnel, and in here you put the filter paper. So why we are using this one? To separate solid from the liquid. So you pour your mixture here, the solid will accumulate with the filter papers on the top part, and you can collect the liquid from the bottom. Conical flask. It's also have a calibration. So based on the volume, you can find different conical flasks in the lab. So why we are using conical flasks? To collect filtered liquids. So you can just put your conical flask under your filter funnel to collect the liquid here. And also we can use to hold liquids that need swirling to mixed. And the next one is tripod. So why is it called tripod? There's a three supportive structures and the flat base. So this helps to support beakers and other apparatus. Like you have so many different types of flask available in the lab. We will discuss more details when we are using this apparatus. And you have a gas mat, so it's a wire mesh. So normally gas mat we put on the top of the tripod because the tripod normally having only the iron based around that. So if you put the gas mat, uh, it will support the beakers and the flasks. And also the other function of this mat is it will, so normally we put the Bunsen burner underneath the tripod. So with this mat, it will spread out the heat from the Bunsen burner. And also you will find different types of stands in the lab. So mostly these clam, and sometimes we can find the boss and clam. So those are used to hold apparatus at a suitable height. So you can adjust the heights. So it will help to securely hold apparatus to the clam stand. So this is showing the evaporating basins. This is a porcelain, and if you want to evaporate a liquid by heating over Bunsen burner, so you put the liquid over here and put on the tripod, and you can use for the high heat. So it's a evaporating basin. And as I mentioned earlier, this is the boiling tube. So it's different to the test tube. So you can heat small amount of liquids. So the boiling tube is much bigger than the test tube. Do you know what is it? So this is called test tube holder. So here you can see you can put the test tube over here, and you can nicely hold the test tube when heating it over a Bunsen flame. Okay, so you will find similar thing. This is called the tongs. You know the tongs that we are using when you are serving your salads or serving your croissants to the breakfast table. Okay, so these tongs we use to handle hot equipment, like if we are uh, trying to boil your boiling tube, you just hold here, okay, and you can flame. So if it is a really hot, use the tongs. So this is called a dropper, or sometimes we call the small pipette. If you want to add a small amount of liquid, right? So what you're going to do, you squish from this end and dip this into the liquid, okay, and the squish here, press. So vacuum is created. So you will take some liquid inside. So it will drag. Then once you release here, you can put the small drops. So what, have you ever used the dropper? Yeah. I hope you try the pH measurement in the lab. Do you remember? At that time you use HClO, sodium hydroxide, drop by drop, drop by drop. So we use the dropper. Oh, this is a glass rod. This is called a styrene rod, right? It's totally glass when we are using the styrene rod. Yeah, if you put something in the beaker, liquid and the solid, so if you want to mix it or stir the liquid to mix substances together, you are using a styrene rod. How about this? Everybody know that. This is called a measuring cylinder. So it's a calibrated, as I mentioned, so you can find range of volumes in the measuring cylinder, right? If you want to measure 100 milliliter of liquid, so you choose 100 milliliter, it's more accurate. 50, 25, or 1 liter, it's range. So have a look around your lab and see how many measuring cylinders you have. So it helps to accurately measure volume of liquids. However, when you draw these equipment, apparatus, or instrument in the lab book, you have to follow a specific drawing type, right? So in your exercise book, right? So you are drawing. So normally drawing should be in pencil. So like in the lab when you are doing experiment, it's a three-dimensional, but you need to convert into two-dimensional. What is two-dimensional mean? Flat or line diagrams with labels for each pieces. Right, look at the beaker. Look at that. How you draw a beaker? Conical flask, measuring cylinders. Look at the tripod. It's a flat. So you didn't mention the third one. But when you see this one, you know this is a tripod. Look at that. What is this? This is the mesh that we talk about, the steel mesh, right? And it's like a board. What is this? Evaporating basin. Sometimes if you are using a Bunsen burner under the tripod, you make a Bunsen burner draw, or you are using a heat like an arrow. Test tube, which is easy. Funnel. Look at the funnel, right? So this is the filter funnel. You see, filter. You can see the funnel, and there is additional layer of filter, right? So we know this is a conical flask. See, conical. And what is this one? This is a round bottom conical flask, round bottom. And we also have crucibles, right? So it is crucibles. You can heat this. This is also made with the porcelain, but you can heat up very high temperatures. So crucibles are very stable. And thermometer. And look at the petri dish. How we are going to draw petri dish. So how we are going to draw the petri dish cover with the lid. Look at that. Did you see? So just have a look your textbooks again and remind each and every apparatus that you are using in the lab and try to sketch. That's the most important thing, because you are not going to attach a picture or three-dimensional thing in the lab. In the scientific way, you are convert this information into the two-dimensional. So I took the Bunsen burner a little bit more explain. Can you see? So this is a tubing. So this will be connected to the gas supply, and you have a base, and this is the air hole. And have you seen this before? There's a collar. So you can rotate this collar, right? You can rotate this collar and adjust the size of the air hole. So why we need this one? By adjusting this air hole, we will adjust the amount of oxygen taken from the air. So it will bypass through the chimney, and this flame is here. So be very careful. You need to be very safe in the laboratory. You can check if they have a more oxygenated air, more air, the flame is a blue color, and try to adjust the color and try to cover the air hole. You can see it will turn to the yellow color. Okay, do all the adjustment with a very safe manner. And the Bunsen burner you can draw in the laboratory book like this. So see, even in the sketch you are showing all the necessary items. So the air hole is an important part of the Bunsen burner drawing. Or you are using an upright arrow. Okay, Now the real example. Can you identify? If you have done any experiment like this, so you have a tripod, okay? See, I told you they have only the outer triangular metallic frame, right? So you put a mesh, metal mesh over there to provide the support for what is this called? This is called evaporating basin. And look at the Bunsen burner. So you can see the hole here. They have a nice blue flame. Now you want to put or you want to record this experiment with a drawing in your laboratory book. How we are going to draw this one. Right, tripod, you remember the symbol? Now here, the perfect Bunsen burner drawing and the flame is there. So this is the mess. Okay. And evaporating basins, yep, like a curve, and you mention the liquid. Did you see that? So then to make a perfect, you need to label. So when you are labeling, you just point out with a nice straight line, right? Take into the one side. Are you going to label like this? Right here, tripod. Are you going to label like this? No, no. It's not necessary and it's not a scientific way. You just point it out with a nice little straight line. Okay, you are not going to cross each other. Okay, how about this? It's a beaker. Okay, you know how to draw a beaker, and there's a liquid here. This is the wire mesh and the tripod, and also they show that the tile piece here and the heat. It's a perfect drawing.